Hello, so my name is Alberto Cruz-Martín. Title of my talk is In Vivo Imaging of the Diseased Nervous System. So this is my lab, Cruz-Martín lab. I want to show you here, this is the goal of my lab is to understand how the brain wires itself during cortical development. Why is this important? We have all of these axons going through the brain and they have to find appropriate targets. We knew from a very long time that this is a daunting task. Axons travel millimeters to the brain and then they have to identify these targets, as you said. We can see here a more modern cartoon and it tells you how difficult this is. Within this tissue, there's also different cell types, and these cell types are defined by different genes. We're beginning to understand how these genes are expressed in each cell type and also their function. So why do we do this? So we know that the genes that are expressed in these cell types and that lead to specific connections happening in the brain also lead to complex behavior through, these are innate behaviors, but also behaviors that occur through learning, watching the parents do things. We have complex behavior. Here I'm showing you an image of baboons in kind of some kind of social interaction. They establish a hierarchy. This is also important to understand mental illness. We know that a lot of the genes that wire the brain, we see deficits in many mental illness. We see deficits in schizophrenia and autism. If we understand this wiring and how it is to function, we could also potentially develop artificial intelligence that has abilities like what we have, so ability to adapt, to assume certain rules. Okay, we are selectively manipulating neural circuits. We have identified several genes that are expressed in specific circuits that are related to this mental illness and that we think might be important for generating this complex behavior. We identify using online tools, using other papers that have been published, and also using, for example, multiplex in situ hybridization. These are techniques that allow us to see transcript and multiple transcripts in different cell types. We're doing all this in the. Once we find these genes and these specific circuits, we actually can now start manipulating. One of the techniques that we have implemented in the lab is the CRISPR-Cas9. We also have the ability to overexpress genes in the circuits. We have a whole many tools in the lab that we have implemented to understand how deficits of these genes and how they affect connectivity. We do in vitro electrophysiology. These are examples cells where we have manipulated these genes. We can do in vitro electrophysiology, characterize electrophysiological properties, and also we can look at network activity of neurons using microendoscopy. So mice are behaving naturally, they're doing tasks, and we can correlate this to neural activity. We can take all of this data and run it through fancy machine learning algorithms to try to decipher how this activity relates to generational behavior. Thank you very much.